Hey, 5.1, solving systems of linear equations by graphing. First thing I want you to do, I want you to work with your partner. Go ahead and do exploration number 1. Okay? Find someone around you to work with. Off you go. This is page 132, your student journal. Alrighty, here we go. So, Logan, what'd you get for letter A there? Alright, C equals 15, then X plus 600. Okay, no parentheses there. But yeah, so we're just taking, we're saying the cost is C, $15 per night, that's a rate. Anytime you see the word per night, or something. Per something, that's a rate.
Number
okay.
per something.
Yep, number per something. And then we add our 600 there. Okay.
I'm not here.
Sebastian, what'd you get for letter C?
R equals 75x.
75x. Good.
That's 5x.
Thank you. Notice your x's represent the same thing. It's a key thing there. So we're going to call them both x. Okay. And then our system. Isabella, what'd you get? Okay. So a system is when you have two of them put together. A lot of times they bracketed them together like this. So our first one would be C equals 15x plus 600. What else needs to go down there? R equals 75x. That's our system. Now, I don't know that you'll see it a lot bracketed together, but so you can write it like that, or it doesn't matter if you use the bracket, but you will see it like that sometimes. Okay? Questions? Once you start on exploration number 2, it continues on to page 133 as well. Okay? But go ahead and start that table up using your information from up above. Okay, so should have our table done. Hey, completing our table, we end up with that there. Where do they match up?
750.
Yeah, cost and revenue are the same at $750. Cost, revenue the same, $750, which is how many nights? 10 nights. Okay, so really what you have here is you have two different equations. You have the equation for cost. You have the equation for revenue. Remember this equation right here, C equals 15x plus 600. This equation, R equals 75x. So taking those two things and putting them into where your break-even point is. When they match up, what's that mean? Good. When they, not when they break even. When they cross. Okay? When they cross. So if we're trying to figure it out, it is right here where they cross. That's where you get the ordered pair 10, 750. 10 meaning 10 nights. 750 is your amount. Okay? In this case, your cost or your revenue. All right. Point of intersection is 1050. This point represents where both functions have the same x and y values. Okay, so our point here, that's our break-even point. That is how you solve a system of equations. When you have two or more equations, when you graph them and plot their point, or plot all points and find where they cross, that is your solution. This point right here will actually be the only value that you could plug into both of these equations and make it true. If I put 10 in and 750 in for R, notice I get 75 times 10 equals 750. That's 750 equals 750. And if I put 10 in here, that's 150 plus 600, which is 750. It's the only value you could put into both equations and make it true. Okay, that's solving a system of equations. So we're going to have three different ways we solve them. One is graphing. That's today. The next 2 days will be substitution, and the final 2 days this week will be elimination. All right. Questions? Okay, I want you to go ahead and take your student journal, look at page 135. Take a look at 135.
I would have thought it'd be 133. But that's 30 or more. Oh well.
Alrighty, I want you to start on problem 1 on page 135. Alright. Lexi, what do you think? Number 1. It is a solution? Or
I think it is 6.
so how many think it is? How many think it is not? Okay, this is our x value, right? This is our y value. Plug them both in. So if I put 3 in here and 1 in here, is 3 plus 1 4? Yeah, it works there. If I put 3 in here and 1 in here, does that work? Nope. So this is not a solution. It only works in one of them. It has to work in both. Okay, why don't you try number 4? Give number 4 a go. That's this one here, for those of you. All right, Isaiah, what do you think? It is? You sure? Positive? Negative 1 plus 4? Is that 3? Works there? That makes plus. Works there? Yes. Isaiah wouldn't be swayed. Well done, Isaiah. Good job. Well done. All right, don't forget this double negative right here makes it plus. All right, substitute inside parentheses always. Okay, if you forgot to substitute inside parentheses, you probably got negative 4 there, which was wrong. All right, any questions? Give number 7 a go. All right, Jilly, what do you think? Okay. How about a solution? What does a solution look like? It's where they cross.
I like it better. It's much smarter.
So our solution is 2, negative 2. There's our solution. To check it, yeah, we just plug it in and make sure it works. So 2 plus negative 2 is 0. That works. 3 times 2 is 6, minus 2 times negative 2, which is positive 4, right? So 6 plus 4 is 10. That works. 2, negative 2. That is the solution. It's where they cross. Okay, I want everyone to find the solution on number 8.
Oh. We were only supposed to do number 7.
All right.
I got 8 and 9 covered.
Number 8, Mercedes, what did you get? Negative 1, negative 3, good. Negative 1 on X, negative 3 on Y, right there. Very good. You can check it, it'll work out. Any questions there? Okay, next page. I want you to try number 10, please. Number 10. Hey, let's see how you did. I expect that everyone can graph these pretty easily now using y equals mx plus b format. So when I'm looking at this, y equals m, negative 1, x plus b. So in this case, b is our y-intercept. So if you don't know that or you didn't remember that, you need to write it down every time you get this paper. M is your slope. Okay? Y-intercept's at 3. Slope is negative 1 over 1. So we go down 1 over 1. So when you're done, double check your line. Say, hey, does it have a positive or negative slope? It's falling from left to right, so it's negative. Got our line there. Take our handy straight edge. Okay. Draw a line. And then next one. Go up to 5. I like to label these. I call this one y sub 1, by the way, just so I remember which one that one is. You go up to 5. B, 1x, rise 1, run 1. So this one should be rising from left to right. If you're wondering what I'm talking about, it means once you get your line in, just double check it. Take a piece of paper and go like this, and as that graph that line that I just drew appears, it's going up left to right. That means it's a positive slope. That's how you double check your slope there. That's y2, our second. Okay, has a solution of almost negative 1, 4. There we go. How many got it? All right. I want you to try number 12. Actually, try 11. Number 11. Tell them what you got.
I figured.
Hey, how about 2, 3-er? Okay, make sure your lines are sloping the correct way, right? So this line, y sub 2, is going downward from left to right because it's negative slope. Y sub 1 is going upward left to right, positive slope. Okay, try number 12. All right, you guys, the reason I had you do 12 is because there's a couple different things that happen on this one. First, I'm going to start with this equation, the second one. I'm going to call that y sub 2, and whenever you're missing an x value, it only crosses. Go ahead. Yeah, it only crosses the y-axis, and it crosses at negative 3. Crosses right here. That is that equation. Okay? If it has an x and a y, then it crosses both. If it has only x, it only crosses x. Okay? This one right here, you could put it in slope-intercept form, or if it's in standard form, meaning x's and y's are on the same side and the constants on the other, always try using your intercepts. So, does 3 and negative 2 both go into 6? Yeah, so 3 times what is 6? 2. So your x-intercept is 2. Negative 2 times what is 6? Negative 3. So your y-intercept is negative 3. All you need are 2 points. Once you have 2 points, you can draw a line through them. Okay? My solution happens to be right there.
We should be using green.
Thank you. 0, negative 3. Good catch. 0, negative 3. Any questions? Last one, number 16. 16. Just because it has words doesn't mean you give up right away. Like, read it, try to write an equation. Be word eliminators. I want you to tell your neighbors what your equations are.
Wait. I thought that was one equation.
Okay, test has 20 questions worth 100 points. Test consists of X, true, false, and Y, multiple choice. So, okay, X, true, false are worth 4 points. So how can you write, like if I have 1 true, false questions, how many points is it? If I have 1 true, false question, how many points? 4. If I have 2 true, false, how many? Okay, so what am I doing there? 4 times X. Okay, multiple choice, worth 8 points each. How am I going to write that as a rate? 8y. And all the points total have to equal 100. So our points equal 100. The way we earn points are true, false, and multiple choice. That equals 100. Okay? How many questions are there? 20. What type of questions are there? So our total number, hello. Oh, neato burrito, thank you. Okay, our total number is X and Y, and they add up to 20. Total number is 20. They're made up of X and Y's. Okay, so we'd have to go through and graph that and use our XY intercepts, what I do on this one. I'd say, well, my x-intercept is cover up the y. What's x?
20.
20. What's our y-intercept?
20.
20. Cross at 20 and 20. That's one of our equations. Now notice this would actually end here. I shouldn't have put that because you can't have negative points and you can't have negative questions. So this is discrete, or excuse me, not discrete, but it's limited to the first quadrant.
You actually can't have half the question, so it would be discrete.
That's true. It would be discrete. Thank you. It wouldn't be continuous either. But I drew the line there. Okay, and 4x plus 8y. Well, if we did this one's a little tougher. I'd have to subtract 4x. We have to divide by 8. That's ugly, man. 108? What's 108?
A party.
A party?
Well, you have 100 people together. What is it supposed
Good.
to be?
Yeah, so that's x. Thank you. 12.5. Okay, did anyone figure out where these guys cross? Where'd they cross? At 12.5?
No, they don't cross at 12.5.
Okay, while I'm handing out the assignment, I want you guys to figure out where it crosses. All right. Hey, what'd you get? 15 what? 15.5. So you say it crosses right there. Anyone else get that? As you'd have to keep going, you have to go down 1 and over 2. About right there. Down 1, over 2. Okay? And as you, another way to think about it, like you're at 12.5. If I want to get to like, say, 10.5, I'm dropping down 2, which means I'd have to go over. No. My rate is 1/2. If I go on 2, I have to go over 4. Okay, and then I'd have to drop down 2 more and go over 4 more, and drop down 2 more, over 4 more, and drop down 2 more, and go over 4 more. That puts me right there. Yeah. About there. Yeah, this is kind of a lame grid for what we're using it for. But our solution is, looks like it's 15.5. How do we check that?
Plug it in.
Yeah, plug it in. That works there. 15 plus 5 is 20. Good. Works out. We got it. All right, so 15, true, false, 5, multiple choice.